A very good morning to everyone. In our last class, we are study about mechanism involved in halogenation of benzene. That is, we are taking the example of chlorination of benzene with chlorine electrophile, right? So this one. Now, today we are discuss about some important points related to this mechanism, as well as it's also related our upcoming topics, that is mechanism of nitration, sulfonation, Friedel-Crafts as well. So first important point, that is number 1, we see that AlCl3, this one, is a Lewis acid and act as a catalyst. But instead of this AlCl3, there are any other Lewis acid can be used as a catalyst for halogenation of benzene? Or you can ask me if there are any other Lewis acid can be used as catalyst for chlorination of benzene. Is it possible? Yes, it is possible. So what are the Lewis acid we can use instead of AlCl3? They are FeCl3, ZnCl3, etc. Okay. Next, point number 2. We learn about mechanism of chlorination of benzene. Fine. So it's a part of halogenation of benzene. But what about other halogen atoms like bromine, iodine? So they are all having same mechanism process because they are all halogens. Yes, they are all having similar mechanism like chlorination of benzene. But what about Lewis acids and catalyst? These things are also same. No, just a little bit difference is there. Now, chlorination of benzene and bromination of benzene, fully same process. Just electrophile is difference. One having Cl plus, that is for chlorination of benzene, Cl plus electrophile, and another one having Br plus electrophile for bromination of benzene. Lewis acid used for bromination, that is AlBr3. Okay. Now there is a very important question. Number 1, yes, this one. What happened, or what is the byproduct if we try to do bromination of benzene in presence of this AlCl3, this AlCl3 Lewis acid? So we have four options. Option number A, we get chlorobenzene. Option B, we get bromobenzene. Option C, we get chlorobenzene as well as bromobenzene both. And option number 4, none of this, means this reaction doesn't take place. Now, what is the correct answer for this? Actually, this type of questions creating lots of confusion between students, but you have to stay focused and try to analyze the problem by theoretically. So your confusion because of this AlCl3, that is Lewis acid actually, right? It's not a similar type of Lewis acid like I would used in my previous example for chlorination of benzene, where you can find that Cl plus, that is electrophile, is there, and AlCl3 which is related similar like chloride, that will be present. And this one also very easy if I am using here Al Br3 instead of this AlCl3, right? Now you know that this Lewis acid actually acts as a catalyst which can fast forward the reaction process, but it remains unchanged at the end of the reaction. So option A is not possible because it's utilized the chloride from catalyst, and there are no any other source of chloride in this reaction. Similarly, option C is not possible because it's also utilized the chloride from catalyst. Now it's between option B and option D. The correct answer is option B, because for halogenation of benzene it doesn't matter which type of Lewis acid we are using, just we have a Lewis acid which is capable of accepting electrons, so that after heterocyclic cleavage generation of electrophile just resists their reversible possibility. Understood? Okay, next. Another very important question regarding this topic, that is question number 2. Why we are using anhydrous catalyst? Why not hydrated catalyst? For this, we have to memorize just our previous lecture, that is generation of electrophile. So this thing happened in our first step of generation of electrophile. Right? So here AlCl3, as I told, is a Lewis acid capable of accepting electrons from this Lewis base, that is our this one. Now suppose instead of anhydrous AlCl3 we use hydrated AlCl3, means it contains water molecule. Now water can dissociate it into H plus and OH minus ion, and this OH minus or oxygen atom carries lone pair. So AlCl3 accepting electrons from the water molecule instead of capturing this one. Then what will happen? So there is no one for capturing this Cl minus in our solution. So it will reverse our heterocyclic cleavage. This one will reverse our heterocyclic cleavage and get back to Cl2, means chloride compound again. So step 1, that is generation of electrophile, become failed, and halogenation of benzene is not possible. So that's why we are using anhydrous Lewis acid instead of hydrated one. Okay. So I hope your all doubts and questions are clear related to halogenation of benzene, and in next class we discuss about iodination of benzene. It's little bit difference from chlorination of benzene. Okay. Now we are going to discuss about our class test questions and answers which has been done in our last week. So first question is, give the IUPAC name for this compound. Here this our compound. Now the options are for this question. Now you have to choose the correct answer. For this compound, I recommended that draw the structure first, like that. Now here is pH. Here is this pH is not a phenol group. It's also benzene, and instead of this part we can use pH. Okay, you can also draw like this structure also. So here benzene is common, so all options you get the benzene is common. Now you have to count the number of carbon is there. So here is 2 and 1, that is 3 carbon is there. That means it's propyl. So that means it's propyl. Now you have to numbering it. So here is 1, it's 2. So in second position carbon it's having 2 methyl group CH3, it's methyl group is there. So it's simply option A, means isopropyl benzene. Understood? Okay. Next, question number 2. Give the IUPAC name for this compound. So here is this compound, no need to draw the structure. So for this compound you have again having 4 options. You have to choose the correct answer. So first you have to numbering the compound. In option you can see that it's having meta para designation. So here our para position, here is our para position, here is ortho position, and here is our meta position. So simply the substituent is present in our meta position. So that means it's maybe option A or option B, because para, between para and meta, which one alphabetically present in first, it's meta simply. So that's why meta is our designation for the substituent. Now you have to count the substituent having how many number of carbon. So it's starting from 1 2 3 4, not from here, because this carbon is present in your benzene ring. Okay, it's present in our benzene ring, so you have to start it from here, or you can count from here also. 1 2 3 4, so there is 4 carbon is there, so that means it's a butyl. And this structure having OH group, means benzene with OH group, that means it's a phenol. So it's simply option A, that is meta butyl phenol. Okay, next, question number 3. This one also same. Give the IUPAC name for this compound. Here is all the options are. So you have to just count the number of positions having the substituent. So the correct answer is for 2 bromo 5 chloro toluene. So toluene, because this benzene ring having CH3 group with it. There is nothing carbon is there, so that means it's a carbon is there. So it's a CH3 methyl group is there. So that's mean option A, 2 bromo 5 chloro toluene, as in the previous one. Okay, next, Question number 4. Which structure matches the given name? It's orthodichlorobenzene. So options are, here it is. So you have to count the ortho position is there. So here is para, so here is ortho, both in are ortho, so it's not possible. Okay, next is it's all about chloro, so bromine is not there, so this one is not possible. Okay, so here is para and here is ortho. Okay, and is para and is, so this one is not possible. So here is para and ortho. Which one alphabetically first? It's first ortho. So ortho, and 2 chlorine is there to substituent, so it's dichlorobenzene. So your correct answer is option C. Understood? Okay, next, question number 5. Now this one is very important. So you having three different compounds, you have to find your correct answer. Okay, so for this type of question you have to find which one is aromatic, anti-aromatic and non-aromatic compound. After that you can check the options. Now all three are cyclic compound, right? All are planar compound, all are having conjugation with it. So we have to check the last formula, the number of pi electron present in this compound. So compound A having 1 2 3 4 4 pi bond with this, that means 4 into 2, that is 8 pi electron. Total number of pi electron is 8. Next is option B. There is 1, 2, 3, 4, 5, 6. 6 pi bond is there. That means total 12 pi electron is present. And here is option C. So here is 1 and 2. 2 pi bond is there. So that means 4 pi electrons. So you have to memorize the series for aromatic compound and anti-aromatic compound. So compound B having 12 pi electrons, 12 pi electrons. Okay, compound C having 4 pi electrons, and this one option A having 8 pi electrons. Okay, now you have to memorize the series for aromatic, anti-aromatic, both. So 8 pi electrons we get in which series? So for anti-aromatic the formula is 4n. Okay, 4n pi electrons, it's having pi electrons. So what we will get? We get 4 pi electron if the n value is 1, 4 pi electron. Okay, then 8 pi electron. Okay, next 12 pi electron. This increases in 4 steps, 16 pi electron. Okay, so we get 8 pi electron in this series, means it's this is the series of anti-aromatic compound. Okay, 12 pi electron also is there, 4 pi electron also is there. So that's mean A, B, C all are anti-aromatic compounds. So you have to select that options having both all three compounds are anti-aromatic compounds. So it will, I think it's option D. Yes, it's a D. Understood? Okay, next, question number 6. Which statement is correct? So this one again also related like previous one. So you have to choose the correct answer, which one is correct. Okay, so here is you have to count because this compound here is already told that it's prevent the planarity. So that means this compound is not a planar compound. Okay, this compound is not a planar compound, so that means it's obviously it's not a aromatic compound, it's not a anti-aromatic compound, it's directly non-aromatic compound. Very simple. Okay, next question number 7. Which statement is correct? So for this compound you have also having several options. Okay, so for this compound you have to check that it's a aromatic compound or anti-aromatic compound, it's a non-aromatic compound as previous one. So the correct answer is for aromatic compound. So you just have to check, count the natural number of pi electrons, so you get your answers easily. Okay, next question number 8. Which statement is correct? Okay, so here is your options. Okay, actually this question is a tricky one. Okay, let's find it's a aromatic compound or anti-aromatic compound or non-aromatic compound first. So this one you have to count that how many total number of pi bond is there, because you can see that it's a cyclic compound, it's maintain the conjugation, it's also having the planarity. Okay, so you directly go for this compound for how many number of pi electron is there. Okay, so we have to count that 1 2 3 4 5 6 7 8. So 8 into 2, that is 16, total number of 16. So 16 number of pi electrons will get in our anti-aromatic compound series. So this one is anti-aromatic compound, right? No, it's not a anti-aromatic compound. I told you that this one is a tricky one. Actually, it's a exceptional case for anti-aromatic compound. It's a pyrene. This compound is called as pyrene. It's an example of polycyclic aromatic compound. It's having delocalized pi electrons. So those pi electrons are present in the middle of the right, is not, it's not participating in the resonance. So we can say that number of pi electron is 14, which is satisfy our Haeckel rule for aromacity. Understood? This compound having different delocalized pi electrons, those pi electrons or pi bonds are present in the middle, this one. It can delocalize all its pi bonds, so that's why in one situation one of its pi bond present in the middle of the structure, and this one is not participating in the resonance in that case. Okay, so we can say that the number of total pi electrons after that is become 14, and which is satisfy our Haeckel rule for aromacity. So that's why this compound is aromatic compound. Okay, understood? Actually, this is a exceptional case for our anti-aromatic compound. It's totally look like anti-aromatic compound, but it's become a aromatic compound. So this one is a tricky question. Okay, you have to remembering this. If you having this type of compound in your exam, it's a pyrene, so your correct answer have to be aromatic compound. Understood? Okay, next question number 9. How many pi electron does the given molecule have? So here is your compound, all the options are. Okay, so it's a very easy, you nothing to do, just you have to count all the pi bonds and lone pairs, so that involves in your conjugation. So there is 1 2 3 4 5 6, so 6 pi bonds mean 12 pi electrons already you have got. Okay, and we have to count the lone pair. So nitrogen, two nitrogen is there, oxygen is there, both having lone pairs. But we know that if the atoms directly attach with pi bond, so that means that lone pair will be not involved in delocalization process, so that will be not counted. But here is oxygen is there and it will not directly attach to the pi bond, so it's having two pair of lone pairs, only one pair of lone pair participation in delocalization process, because there is double bond, single bond conjugation maintained by the lone pair, again single bond, again double bond. Okay, so this one will count it. So 2 pi electron is there, 2 pi electron is there, so total 12 plus 2, that is 14. So your correct answer come 14. Understood? Okay. Next, last, that is question number 10. Which of the following statement is correct? Aromatic compounds. So it's a statement from aromatic compounds. You're having different options. Okay, so you have to just find the correct one. Which statement is does not go with aromatic compounds? So aromatic compounds are planar compound. It's having so this one is correct. It's having cyclic structure, are generally less reactive than similar substituent alkane. Its statement also correct, because aromatic compound are most stable compound in our chemistry. So most stable compounds are less reactive. Okay, so this statement is also correct and it's having conjugation also correct. The formula is for aromatic compound, that is 4n plus 2 pi electron. So that is the formula for aromatic compound, and this one is formula for anti-aromatic compound. So option B is the incorrect statement for aromatic compound. Okay, understood? So I hope you get all your answers and understood why your answer is correct or maybe wrong. So for today's class, that is enough. Thank you everyone.